You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening wherever you are. We're coming to you from Boston, Massachusetts. Today is September 29th, 2021. Happy fall for everyone that experiences fall. I know in the Northeast it's quite beautiful, and maybe in the Midwest, but I haven't experienced fall out in Colorado.
Maybe it's too cold. Like it's already 50 today.
I know it's getting there. It's coming in head fast.
Yes.
I hope everyone's doing safe, and we're gonna dive into today's episode. But before we dive into the news and topic, we are going to be having another guest, which we did tease in the last episode. Umair Mufti is one of the product owners within Pure, working on sort of a database as a service that was actually recently announced. So we're going to definitely talk about that a little bit. He's one of those guys that's worked at various different data service operations jobs. One of the ones that we know he came from was Dreamworks Animation, where he led sort of the adoption of site reliability engineering and developed and built a database as a service platform in Dreamworks Animation. So we're going to ask him a lot of questions, I'm sure, about his experience on that. He's also an avid Dodgers fan, so how you feel about that is up to you. But yeah, we're really excited to have Umair on the show in just a bit here. But I think there's some cool news going on in the world of cloud native storage, Bhavin.
Yeah. So one of the things that I saw Google announce this week was early access for backup for GKE. I think they're just getting ready for the Cloud Next event next month. So this is just one of the things that they announced. Now, again, still in early access, but customers who are using GKE can use a data protection solution from Google that allows them to protect not just your applications, but also the cluster state for GKE into an object store bucket, and then restore it to the same or a different GKE cluster in the same or a different Google Cloud region. So customers who have all of your workloads or Kubernetes clusters running in Google Cloud, this might be a solution for you.
Yeah, I think, if you have sort of a tool that's built into GKE, I mean, I know every time I spin up a GKE cluster, it's just stupid simple. So I think they've done some really good tooling out there. Wasn't there also part of that announcement was the file system support that supports replication across 3 availability zones in a region? That was, I think, yeah.
I think that was more generic to Google Cloud. I like it obviously works with GKE, but I think it also was focused around their NAS offering.
Yeah, and I think for Kubernetes, like if you consume that, you get sort of some local high availability, but also with the backup product, you get some backup built into your Kubernetes workloads. So yeah, really cool stuff. What else has been out there? I know vSAN 7 update 3 came out, which has some, which I only saw this morning. So I know we're still diving into the details there. Probably be great to have someone on post VMworld to talk about what's going on in that space, even in the Tanzu space. I know you've been doing a lot of work there, but I think they've added some, officially the file service capabilities, the stretch clusters for vSAN. So really some cool stuff there.
Yeah, I'm looking forward to like VMworld sessions, like deep dive sessions from some of the TMEs there, to look in to learn more about these topics and see what's new in vSAN 7 update 3.
Yeah, exactly. And then we wouldn't be doing our job if we didn't talk about the Portworx Data Services announcement from Pure, and that's near and dear to our hearts. But that's one of the most exciting things that we've been up to lately is really working on this sort of database as a service for Kubernetes, and we're actually going to have Umair, who I mentioned, the product owner of PDS come on and tell us really about his experience of why he started developing, Portworx Data Services, or even before that, database as a service at other companies, what drove him to go down that road. So I'm super excited to talk more about this topic since it's so
Yeah, and
new.
don't worry, guys. Like, this is not going to be a sponsored episode. We are not going to spend the whole episode talking about Portworx Data Services, but it is a pretty cool announcement.
Yeah, exactly. Like I said, we have to do it. We have to say it. And if you want to try it, go for it. There's a sort of early access you can sign up for. But Umair has a lot of experience beyond, just his short tenure here at Pure. So we really want to dig into that. And that's going to be definitely more generic about, just data services on Kubernetes and why you try to do this for an organization as sort of an as a service and why it matters. So I think that's a good intro. Should we have Umair jump on?
Yep, let's do it. Let's bring him on.
So welcome, Umair. Welcome to the show. Welcome to Kubernetes Bytes. I think the audience is really excited about this topic. We're excited to have you on, especially since you're an LA Dodgers fan. We're over here in Boston on the other coast. Please tell the audience a little bit about yourself and your background with Kubernetes.
Sure. Yeah. Excited to be on the show. Thanks for having me. So as you mentioned, I'll actually talk about the Dodgers a little bit because as of this recording, Dodgers are looking good and hopefully will come out on top for the 9th consecutive year. Again, thank you for that Mookie trade that really helped out quite a bit. So just a little bit about my background. And specifically around Kubernetes. So my Kubernetes story or journey actually kind of began in my last job, which was at Dreamworks Animation. Interestingly enough, I actually kind of go back a little bit before Kubernetes. So when I joined Dreamworks, I joined them in about 2014, or actually exactly 2014. And I was hired there to be a database administrator for Cassandra. Mm-hmm. And in my previous to Dreamworks, I had done some work on, I had a startup and we had kind of hacked at Cassandra to make it into like a real-time analytics database. So I had some fair amount of experience with Cassandra. And right around that time, Dreamworks was beginning a journey of moving into the microservices world, I think as a lot of companies were at that time, and starting to think about databases outside of just Oracle. Up to that point, they were just kind of sticking everything inside of Oracle schemas and not thinking about it too much. But the guy that ended up hiring me there had a really forward-looking vision about the way that that databases should be kind of thought of, and more NoSQL and eventual consistency models and that sort of thing. So he was like, let's start with Cassandra. So they brought me on board, and within my sort of first, and this is January of 2014, right off the bat, like my first project there was like, let's figure out how to get Cassandra to run inside of a container. Mm-hmm. And at that time, containers didn't even mean Docker. So this is like LXC days. This is like before, this is like really super early. So obviously before even Kubernetes existed, right? So there was no Kubernetes. There was barely Docker. I think Docker, maybe Solomon had mentioned it or something at a previous.
Yeah, he was doing early demos, I guess, at PyCon.
Yeah, exactly. And so about a month later, my boss Ali and I went to the Scale Expo. I don't know if you know it, here in Los Angeles, and it's like a Linux expo. And we just sat down over lunch and we're like, you know what, we should build a database as a service. We should think of Cassandra as a service to our team internally within DreamWorks. And and so that kind of set me off on this like 8-year journey of trying to make this happen. But so early on, again, this was sort of pre Kubernetes. We were experimenting with first LXC containers, then Docker containers. Docker, when it first came out, it didn't, even Linux containers at the time didn't really have any notion of network namespaces or a lot of these sort of new primitives that we have to think about in terms of isolating workloads inside of containers, or just isolating those workloads generally. And so we kind of had to build a lot of that stuff from the ground up. And then fast forward to the Kubernetes world, maybe like a year later, 2015, I started seeing Brendan Burns. I think he was still at Google at the time, and he had his project for Kubernetes, and we were literally like, oh, this is great. I can have somebody orchestrate the containers for me, because up to then we had implemented what we call meatware, which was us, just a bunch of humans going in there and being human schedulers and saying, okay, this Docker container is going to run on this machine, and if that container goes down, then I'm going to start a Docker container on another machine and change IP addresses and manually move over, like copy the data over to this other physical machine. And so the notion that there might be something that could kind of orchestrate some of that work and take it away from humans was really appealing to us back in 2015. And so I was literally, I had built a system to pull down source code from Git and compile it, build it in RPMs that we could deploy our own Kubernetes clusters. And literally by the time the job would end up building, there would be more commits on the source code, and like things would be broken. And it was almost like it was like this endless loop for about 2 months of just trying to compile and get like a stable build of Kubernetes. Finally, when that happened, by the time I got like some stable builds, I realized that it completely was missing any sort of notion of I'll just say state. But it's like, okay, this is great if I want to move a pod around, but what about if I need to save that data to somewhere? So I was like, so we basically completely scrapped Kubernetes for years and continued forth on our own. We built our own platform, and it wasn't until the Portworx guys actually came to us a couple years later. This is actually kind of interesting. So the Portworx guys had come to us and said, "Hey, we're building this thing called software-defined storage. We think it could help with your Docker containers." Again, this is before Kubernetes had stateful sets or any of this stuff. So we were still doing things in just raw Docker. And so we started looking at, software-defined storage. We can actually use this thing called Portworx to manage this data storage behind our Docker containers outside of Kubernetes, just like on our bare metal machines. And that kind of started us down the path of, as we kept upgrading Portworx and started realizing that the Portworx development effort itself was starting to move away from Docker and into the Kubernetes space. And all of the other Portworx customers, by the way, we were like customer number 2 for Portworx. We were like super early, but we started seeing the development effort move away from Docker and kind of sort of congeal around Kubernetes. We're like, okay, maybe we need to look back into Kubernetes. And by then, stateful sets had been really, had come out, and that started us down what we thought was going to be, an easy path to making databases run on Kubernetes, but that's a whole nother story. So, anyway.
Yeah, I mean, I think because at that time, right, Docker Swarm and even Mesosphere at the time were sort of seemed like the front runners, and then once Kubernetes really matured, right, that it was pretty much lights out, I feel like.
Yeah, for sure. And so even Docker Swarm, like for us, Docker Swarm never made a lot of sense. It seemed like it was more work than it was worth. Mesos, we had done some POCs with Mesos. We actually, I don't know if we, I probably shouldn't say this publicly, but we did some work on kind of POCing DCOS, comparing it with Kubernetes. There were a number of issues that came up with running Cassandra in DCOS that we actually basically determined that our own solution, our own platform that we had developed that was basically just raw Docker, was actually superior than Mesos. And we started telling them, hey, this is the Mesosphere guys. We'd meet with them and be like, you guys have no notion of network namespacing at all. So if I need to run 2 Cassandra clusters on one on one node, one
Mm-hmm.
server, I have to expose different ports and have some sort of port mapping. And I'm like, this is not going to scale if I have more than like 2 databases.
Yeah, I mean,
Uh,
you really, when I was at Athena Health, we originally went with Mesos and Mesosphere because the maturity level it was at the time, and the universe packages were appealing for certain they had Kafka universe
mhm,
packages, they had
mhm.
all those things, and then I think we realized down the road as well that the universe packages were very very opinionated, so it was hard to change things. You still had to
Yeah,
pin certain things to nodes, and that sort of
yeah,
defeated a lot of the purpose, and then our eyes wandered towards the Kubernetes
yeah.
in the room.
The,
So
the Mesosphere guys had actually asked us to start contributing our stuff and put that into the, like, basically they wanted us to become the provider of some of these frameworks or whatever in DC. Anyway, so it was but like you said, I mean, I think by then a lot of the industry was already starting to see that Kubernetes was going to be the path forward. Um, and it obviously look at where we are a few years later. I mean, it's like conquered the world. So yeah.
before Portworx came to you at DreamWorks, or to that team that was building
Mhm.
this, did you try to manage any of the state components yourself? Right, there was some primitives still around at the time,
Yeah.
and like you said, Portworx was early, but did you try any other either solutions, open source, or pinning to host paths? Like
Yeah.
I've heard
So
of all of those.
it was a lot of that. There was no solution from a vendor or anything that we were doing. We were just trying to figure out how to do it on our own. So it
Yeah.
basically the solution ended up being it was a lot of host mounted volumes, and then doing things around labeling of where those volumes. So on top of just the Docker, we had kind of built like uh, a config man. We use config management to
Hmm.
to deploy out those containers. So I'm going to get into a little bit of the weeds. Sorry.
It's
Um,
okay. This is great.
Yeah, we
yeah,
love
yeah.
that.
So the containers themselves were one thing. Like we'd have our own container images, but even within them, even those we wrapped in unit files. So we were a Red Hat shop
Okay.
at DreamWorks, so everything was systemd. So we had our own unit files that we would effectively create on top of a host. So there was like a unit file, and then we had like config management that would not only go and create that unit file there on that host, but also create a bunch of logical volumes, and then configure the unit file to use those logical volumes, so that when you did, for example, service, uh, foo up or whatever it is, it would automatically mount those volumes, and it would be kind of pinned and we'd also like inject like IP addresses in there. So we at I don't know how much I should say about their environment, but basically there's a flat network. And so the idea being that any Docker container that we had started anywhere in the studio would have a dedicated IP address, and that
Okay.
so then that container could be routed to from anywhere else in the studio. Um, and some of that thinking has gone into later, like the Calico guys, or who turned
Hmm.
into the Calico guys, had come to us again very early on, and uh, what they were showing us that they were thinking about in terms of just the project and sort of their BGP solution. It was a real easy fit for us, because we were like, we do exactly this already,
Hmm.
except we don't use BGP. Um, we use a different protocol, but other than that, it's the exact same thing. And we just set up our own Quagga routers on every single one of our Docker servers that manages the networking layer. So anyway, that was sorry, I went on a networking tangent. I don't know what you're asking
It's
about.
okay. We ran almost the exact same thing, but with BGP
Really?
at Athenia Health. So yeah,
Oh,
it was. We managed all the Quagga configuration, everything with Ansible, and it was. I would say it worked great when it worked, but it definitely needed a constant maintenance.
yeah. I mean, for us, it actually worked great.
Yeah.
The only problem ever was just uh, tracking the allocation of subnets and making sure that, hey, I'm standing up a new Quagga router over here. Let's make sure that the network that I'm assigning to it is, unique inside of my, we had like a /16 or something that managed like all the IPs for all of the containers. But anyway, on the storage side, the answer to your question is no. We never looked at sort of an automated or vendor solution. We maybe we were naive, or maybe we just never found it, or didn't look hard enough. But it was always, we're just going to host mount volumes, and
that was pretty common, I feel like.
Part of that also was we were doing everything on bare metal, so we didn't have any. We didn't have to worry about, like, we felt like we could get away with, or we not even we could get away with. We needed sort of that like line level speed. These were databases that were running inside of these containers, and we always wanted we had maybe a misconception that if we had any sort of software layer in there, that it might affect the performance. And then the Portworx guys actually kind of cleared that up for us. Like, they would showed us demos. And the great thing about some of the early stuff that Goo and the other guys at Portworx were showing us were around like this can actually increase your performance. So first of all, you can tune the IO profiles, and you can say, hey, I want to f-sync at, I want to bundle up my f-syncs and send them at this rate, which was like eye-opening to us. But then also, like, parallelizing read requests across multiple nodes could actually, make your read requests faster than what we were doing by just hitting a single, volume on that host. And so we're like, whoa, okay, there's something here.
So in this journey of like going to as a service, you obviously you were responsible for Cassandra. Were there other data services or databases that you were looking at too, and doing all of this in parallel? So you had to figure out how to run all of those on the same bare metal servers, or was this like, oh, let's try Cassandra first. If we figure that out, we can extrapolate and bring in other apps as well?
Yeah, very good question. Yes, there were many data services there. So we started with Cassandra. That was kind of, we figured if we could prove out that Cassandra ran in a container and sort of on demand, then we could probably do that for other things. So the sort of the early working backwards, as I mentioned, we kind of had a platform to automate this stuff with config management and unit files and stuff. So what we wanted to do, or what we thought was the right way, was the thing that's ultimately getting deployed, the thing that's containerized. Let's treat that as a commodity and not care whether that thing happens to be Cassandra, or happens to be Elasticsearch, or happens to be Mongo, or in total there were like over 10 different data services that we ended up doing this for. So it's like, let's not care about what it is that we're deploying. If we say that, if we all commonly agree that Elasticsearch is going to behave the same way, or Cassandra is going to behave the same way, then all we need to worry, then all those things can basically be deployed using the same automation. So that same template that we had for the unit file could be used. The same config management tool that we had that would create the files and set up the volumes, and all that other higher level automation we could just plug into. And so then the core of our work started turning into, okay, what is that common set of interface, if you will, or what is the specification for that application in order for it to be deployed using the other tooling. So we basically created what we called, there was an internal project at Dreamworks called Stella. And so we basically created this Stella image specification. And so we knew if the Elasticsearch image met that specification, then it could use the rest of the tooling. Or if Cassandra met that specification, it could use the rest of the tooling. So yeah, we ended up blowing out beyond just Cassandra into many, many different data services.
Got it. I think a natural question I have is, database as a service, or getting a production database in Kubernetes, takes a lot of moving parts, right? You've gone into networking, you got persistent storage, you've gone into configuration, right? There's a lot of things to do here, and I think I think we're getting a good sense of of why building a service like this mattered to your team at DreamWorks. But I think the question here is, you know, if you were thinking about running production level, production grade databases on your Kubernetes clusters, say, fast forward today, a lot of organizations are running Kubernetes today. A lot of them are running stateless components and stateless services, and they want to add databases. Do they go the route of building their own database as a service, right? Finding all those layers and what works for them, or do they look for sort of a solution like you built at DreamWorks? I think, I don't know how long it took you to go from conception. It sounds like around 2013 or so to a workable Stella in production. But I'd love to hear your opinion there.
Yeah, for sure. So I only touched on sort of like the tip of the iceberg on what we ultimately found out is like even harder than just figuring out networking and storage. To be honest with you, some of that stuff in the end ends up being the easy part. And most of that journey that I was talking about was even before we got to Kubernetes. So that was just in Docker, right? And there's some added complications which I'll get to in Kubernetes, but there's also tooling and primitives and that sort of stuff that made it easy. Like, I don't want to say easier, but made it possible to accomplish in Kubernetes. Some to automate some of the things that we were doing again as meatware at DreamWorks. And so, so the first thing is the first thing like we should really talk about when we're talking about databases. And we thought early on, there's this notion of a stateful set that Kubernetes has now, and so that's going to solve all of our problems with state. And what we quickly realized is that was not true. And Portworx had come along and done a great job with software-defined storage and did answer the problem of state, where I'm going to save my data. But what our team discovered is that that's not the hard part about running a database in Kubernetes. The hard part is that most of these database applications are actually distributed applications. And even to this day, if you look at when people are talking about pods or talking about containers or images, it's always on this notion that the image that I'm building fully encapsulates an entire application, right? It's like, okay, if I want to run Nginx, I just deploy this Nginx container, and I have a fully running Nginx, pod or container that's running here, and that's great. But databases aren't like that. Databases, for the most part, are distributed systems. And so when I'm talking about Cassandra, I'm not talking about a Cassandra container or a Cassandra pod. I'm talking about 3 of them running or 7 of them running. And how do they communicate with one another? And how do they know that if a pod starts, and this is where Kubernetes makes things hard, right? Is this notion of like this ephemeral nature of your pods, where when we were in our old raw Docker system, we didn't have to worry about IPs changing or things moving from one server to another or any of that stuff. But we'll come to that. But in any case, so if I have a 3-node Cassandra cluster and I want to scale it to 5 nodes, how do those 2 new nodes know where the other 3 nodes live? How do the other 3 nodes that already were there, how do they know that the nodes that are joining, that they should be part of the cluster? Or in a more likely scenario, let's say I had a 5-node Cassandra cluster, one pod crashes, Kubernetes reschedules it and brings it back up. How do I know that new node that's joining is the same node that crashed earlier and not just a new node so this whole notion of like cluster membership and failure detection for distributed applications, those questions were really hard to begin with. To, like, as you know, like the 2 hardest problems in computer science are naming variables and distributed systems, right?
Nice.
So it's like these are not easy things to solve outside of Kubernetes, and then trying to containerize these applications and figure out how do I deploy them in a robust manner inside of Kubernetes is really where the challenge is. And this is where you have to get in at the application level and understand what the applications are doing. So what I was just describing about with the Cassandra cluster membership, those questions are answered completely differently for Elasticsearch or for Postgres or for Couchbase or for like Kafka has, their own system. So um, like there has to be an application level understanding for each one of these things, and whatever system you build and whatever images you build have to be aware of what is specific to Cassandra and how do I how do I re-replicate the data in a Cassandra cluster? How do I repartition data in Kafka and those types of things? So I forget what the question was. If the question was, do you want to handle this stuff yourself? It's a lot. It's a lot to think about. And if you maybe just have one database that you care about and you have the expertise in-house to both know at the application level what it means to repartition your Kafka data, and also at the Kubernetes level where you know how to create that automation, whether it be as an operator or just building the images and all that stuff, then I would say you are in the minority. They're
Yeah, only a few
having that
big
overall.
organizations have those kinds of resources, right, to dedicate to each
Right.
different data
Yeah, I mean
service.
it's a Venn diagram, right? And the overlap of sort of the Kubernetes expertise and the database expertise, the that overlap, unfortunately I don't think is that great in volume.
Yeah, not very large. I mean, that's definitely, I think what we've seen in our day jobs is, you know, uh, organizations are using Kubernetes as a de facto container orchestrator, but there's still many of those are early days in considering, okay, if I want to run my staple things on there like the Cassandra and Kafka and Elasticsearch that you're talking about, that's a whole new set of concerns, right? And the question was really around like what other things besides persistent storage would you really need to consider to run a production database? And you've answered a lot of these, and I think one of the important one I heard was stateful sets didn't fully solve the problem because it was a Kubernetes level abstraction, and you need that application level integration. I think a follow up to that would be, now that operators are around, does that help in this story, right? Or are there still, things that you would build into a database as a service that even operators don't really kind of target?
For sure. Yeah. So for sure operators help. And but they're also required because of the added complications that Kubernetes has. Like I was saying, with that ephemeral nature of a pod, it can be reassigned a new IP at any time. So, now you have to code for that. And the only place to code for that and have that logic would be in an operator. And we'll come to that in a second. I just want to point out, like, there are other complications besides just, we talk about cluster membership and failure detection there. And I don't need to go into detail about them, but like the other really big thing that's complicated with these distributed applications, and again, it is because they're distributed, not because they're stateful, but because they're distributed. There's this notion of ingress, and I use ingress with like a lowercase I, not a capital I, not like the ingress object in Kubernetes,
Sure.
but just the notion of directing traffic into your pod. And the reason I bring it up is because, again, these things are distributed systems. So imagine, let's talk about a Postgres cluster, for example. So maybe you've got a three pods that are running that are a Postgres cluster. One of them is a primary, and the two of them are replicas, right? So from a client perspective, when you're writing data or when you're using that Postgres cluster, you need to send your write requests to the primary, right? You can't send your, insert values into your secondary or your replica because it'll fail. So you have to know how to find that primary. Likewise, if it's a read request, you could maybe send it to any of those three, but most of the time you would want to purposely send it to a replica because you want to offload the traffic from the primary. So there's this notion of being able to direct traffic into specific nodes in your distributed application. And that's something that the native Kubernetes primitives don't allow for right now, right? You've got a notion of a service which is backed by many pods. But what it's really going to do is it's going to load balance the traffic between your 3 Postgres pods, which is really completely useless for Postgres or for any database or for any distributed application. And so the way you get around that is by creating your own custom resources or your own objects in Kubernetes to handle that logic, both to create the primitive, the custom resource itself, and then also the logic of how this thing should behave. So that's the operator, right? So you've got your CRD and you've got your controller that's handling all the logic. So for sure, you need at a minimum, if you were going to create this system by yourself, you would at a minimum need to use operators to solve some of these problems. And to their credit, a lot of these database vendors, a lot of these ISVs realize that also and have started creating their own operators. Certainly Crunchy's got one for Postgres.
DataStax just moved from Helm to an operator for their Cassandra as well.
Yeah. Side note, I was very involved in the community for DataStax and the Cassandra operator development.
Awesome.
Been working with that team for some time as well. Honestly, offering a lot of some of the lessons learned that we had at Dreamworks from the Stella development and the Stella operators that we had built, and kind of trying to guide, some of the, how do you handle some of these things?
Which I imagine could be an entire podcast episode in itself. The lessons learned.
Oh yeah. Oh, for sure.
Because we're getting towards the end of our time here, I wanted to sort of ask one more question, which is, it sounds like there's a lot of components that go into database as a service. There's, the deployment, the administrative tasks, the how do you have clients, the ingress, the managing distributed systems and members. And, it is a very complex, orchestration of things. And so as a team, and maybe this relates back to your original decision of why you chose to go on this 8 or 9 year journey that you've been on of why did you decide that this was a good fit for your teams at Dreamworks, and why would an organization or a team, gravitate towards a database as a service technology rather than trying to figure out all these Kubernetes primitives or using operators?
Yeah, for sure. So at Dreamworks, the goal really was to provide a platform for our developers, right? We didn't expect our application developers, the ones developing out the microservices, to either know anything about databases or to care where they were running, right? It should have just been abstracted from them. All they care about at the end of the day is a connection string, right? I'm developing a new microservice. It's got a Couchbase backend. Just tell me what I can connect to and where I can insert my data. The ops team, the DBAs, you guys figure out how to keep it running and make sure it scales and do all that stuff. So that was the vision at Dreamworks, is just to provide a connection string, complete abstraction for developers. Here's a platform, and that you can spin it up on demand with an API, whatever it is, or go to UI, and you've got a database, and here's your connection string, and that's it. And so that it's the easy button for them, right?
Got it.
And what what I've had a great relationship with the Portworx guys, as I mentioned, over the years, and in having shown them what we had built at Dreamworks, like, I think they immediately got that there was an application for for all this hard work that we had done. And so, my work here is continuing in solving all those hard problems and making that available. And like, here, we think all developers, regardless of where you work or whatever even the size of your business is, if you're a startup and you're a developer, if you're developing an iPhone app and all you care about is a database endpoint, or if you're in a big multinational telco and you're an application developer, and all you want to focus on is your is your application and you just need somewhere to insert data, like that's a common thing across organizations of different levels of sophistication, market size, and firmographic, segmentation, whatever, right? It's a common need. And so really the idea is like, okay, let's let developers just focus about their applications in the same way. As I went through like all that complicated stuff, it becomes obvious, like if you want to solve those problems yourself, sure, you might be able to come up with an implementation. It might be naive, it might be sophisticated, but keeping that implementation, you know, have it evolve over time, make sure that when version 1.22 of Kubernetes comes out, it doesn't break, or when Cassandra version 4.0 comes out, as it did, like the changes that they made in their architecture don't break your automation. In the same way, like hopefully people know that like these are hard problems and you need a dedicated team that's constantly answering these questions and responding to them. In the same way, like, sure, I could build my own password authentication system for my application.
Why not?
But it sounds easy, right? Or, I can understand that when I start keeping passwords and storing them and I started getting all sorts of compliance issues and I have to like, there's so many things that I need to worry about. I'm like, oh crap, maybe I should just let somebody else, do the heavy lifting here.
Yeah, I think those are words of wisdom to end on. I think here is let someone else worry about it.
Make your back
think
office somebody else's front office.
Yeah. Exactly. So I mean, I think it really shows that these systems of running stable components on Kubernetes are complex, hard to manage. You have to continue to maintain them, and if you're running a single database or those kind of things, like sure, but once you start scaling and you're running distributed systems, like having that easy button is so important. So I've learned a lot today, Umair, and it's been such a pleasure to have you on
Sorry
Kubernetes
for blabbing on
here.
so much.
No, honestly,
no, I think
yeah, these like details are really important, and you can only talk about these if you have gone through the process, right? As you said, it took you like 7 years to build a database as a service platform that you felt was easy enough for use like by developers who can just use a UI, use a CLI, ask for a connection string, and that's all they care about. So it takes time for every enterprise to reach this point.
Yeah. Amen.
Well, Umair, thanks for being on the show. Really appreciate it. And until next time.
Sure. Let me know if you want me to come back for that deep dive on
lessons learned. I think we might have to have you on here. Yeah.
Let me know. All right. It's really great talking to you guys. Thank you so much.
Thanks, Umair.
All right. Take care.
All right. Bye.
Well, that was, I think, fantastic. I don't know about you, Bhavin, but I really enjoyed that conversation with the mayor. As we have more guests on the show, whether we work with them for long periods of time, short periods of time, or not at all, I think it's really eye-opening to hear their background and why they did things, especially with the mayor's experience at Dreamworks, right? Conceptualizing the whole thing and why he wanted to do it. That was really interesting. What about you?
Oh yeah, like I know the episode ended up being a longer one, but there was so many great details, like the level of detail that he was able to go into and discuss his 7-year-long journey about building such a platform. It's all about the identifying your risk reward ratio, right? Like if you are going to bet $1,000 and if the reward that you're going is also 1,000, you might not be willing to put everything at risk. But then if by just placing a bet of $1,000 you're getting like 10,000 in return, that's where you should be investing your money. So that same thing applies for building a platform. Like if it's going to take you 7 years, it might take you a long enough period of time to earn the rewards. But if you can just rely on a vendor solution, somebody who has gone through all the process, you can get to those rewards really quickly and start adopting these new and modern solutions like right now instead of waiting for 7 years. So that was like one key takeaway for me. Like instead of spending all the time and resources, I should just look at people who have done this before, gone through the same journey, and know what the best practices are for building such a or operating such an as a service platform.
Yeah, I would absolutely agree with that, right? Figuring that out as an organization is key. I think for me, what struck me is just the complexity of the whole thing, right? Obviously, 7 years, it's not an easy thing to do. So, taking the approach we often look at a problem, especially on this podcast, from the storage perspective, the data management perspective, we really hone in on those pieces and those data services. But when you really think about a data service is really just another application. Any application could be a custom built application that isn't a database. It's still going into production. It needs a lot of things, right? It needs the monitoring capabilities. It needs user friendliness. It needs the networking components and all this other complexity that gets wrapped into this easy button, right?
Yes.
That Umair was really driving towards. So I think it really showcases just some, how hard some of these problems are. And Kubernetes, to the point he made around stateful sets and operators, is that those help with some of the problems you're trying to solve. But Kubernetes doesn't just solve things for you, right?
It's a platform for building things. Like it can give you an orchestration layer, but then you still have to figure out all the additional details around any application that you might want to deploy, a data service or not.
Exactly. So, full circle, don't build your own database as a service. go and use one. There's a really cool one that just came out. I'll say that one last time. Go take a look at it. But if you can, and please want to review this podcast, do that on Apple Podcasts or wherever you can review podcasts. We are going to have another guest on the show talking all about how you can use Kubernetes as a team of one for really managing and scaling if you don't have a whole team of engineers, which I think may be near and dear to many of our listeners. So that'll be exciting.
It sure will be. Like, it's not just about people who are getting started and like are just that single person on the team, but if you are the pioneer, like if you want your organization to adopt Kubernetes, how can you get started with Kubernetes on your own and then bring in the larger part of your team? So it will be a learning experience for everyone.
Yep. All right. Well, Bhavin, until next time.
Yeah, that's a wrap.
Thank you for listening to the Kubernetes Bytes podcast.